If we're going to avoid being at the mercy of these world events, we've got to have a sustained, all-of-the-above strategy that develops every available source of American energy. We have a supply of natural gas that can last America nearly 100 years. The development of natural gas will create jobs and power trucks and factories that are cleaner and cheaper, proving that we don't have to choose between our environment and our economy. This country needs an all-out, all-of-the-above strategy that develops every available source of American energy.
We are very fortunate to have an ample source of natural gas in this country. That natural gas is buried deep below the ground. We have to get it out. That involves drilling. Anytime you go after resources like that, you have to be aware of what the extraction process does. How does it affect the environment? How does it affect people? To understand natural gas, and for that matter, any type of energy source, you have to understand how you acquire it.
Perhaps the most dramatic discovery for the American energy picture in the last decade has been the ability to access the gas that's stored in the shales around the country. We now have gone from projections of decades of gas to centuries of gas.
Not only do we have an abundance of natural gas being produced more than we expected, but the projections are that this is going to continue to rise.
There's no question that shale has become very important to our overall energy supply picture. There are several reliable estimates that 50% of our daily gas supply will come from shale resources.
A shale is a dense, low porosity, typically about 5 to 10% porosity. The pores of these rocks is what contains the hydrocarbons. That has very low permeability, which means fluids have a really hard time flowing through the shale.
The problem is it's trapped in little chambers or little openings in the rock. How do you get that out?
So what you do is you bring your rig to your surface location, right? So you're on top of the land. And the first thing you're going to do is drill vertically some distance. For the shale gas plays, it's usually about 8,000 feet, something like that.
The first hole that's drilled is quite a wide diameter, and their surface casing is run in that hole and concreted between the casing and the rock formation. Then later, when we drill several thousand feet more in the vertical well, intermediate casing is run, so there'll be another smaller set of casing run inside the first.
After you reach your vertical depth that's desired, you would then go off horizontally and place a lateral that's about 4,000 to 6,000 feet long.
It's at that point that we will fracture the rock. People will pump down using water, typically, under high pressure, some kind of a material, usually sand, down into the casing. The sand will push through and force the shale to break up.
The primary reason we use hydraulic fracturing is to ensure that we have sufficient contact area with the wellbore so that the gas or the oil can flow from the formation, from this kind of rock, to the wellbore.
So basically, the rock is being modified now by this hydraulic fracturing technique, which makes all the shale revolution possible.
The good news of natural gas is that it's domestic and relatively affordable and relatively clean. But at the same time that there's good news, there are environmental risks from its production, from the extraction of the natural gas. And those risks started with the surface, with the topographic disturbance. There's a drilling pad, about an acre in size, that is cleared of trees and grasses, and so that's a disturbance on the land. There are trucks that come and go with different equipment or different fluids, or water for injection, that kind of thing, and those trucks take a toll with noise and air pollution. And then you bring up the gas along with all the fluids that you put in, plus other fluids that were naturally present.
A lot of this is happening in parts of the country that aren't used to large-scale energy development or even to large-scale industrial development, and so you have challenges in the local communities that have to be handled properly.
One of the major concerns with fracking and shale gas is the possibility that it's going to lead to contamination of drinking water, contamination of aquifers.
Now, most of the time, the shale development and the presence of hydrocarbons occurs at depths of 6,000 feet or below, whereas groundwater typically is found in shallower formations, typically a few hundred feet from the surface. And so the groundwater is separated from the hydrocarbon resource by thousands of feet of rock. And that really provides you the buffer that you need to ensure that any fluids that you inject into the shale formation is not going to make its way into the groundwater.
There have been instances, fortunately very rare, where there have been problems with the surface casing and intermediate casing. These are not instances where the fluids that got into the groundwater came up through thousands of feet of rock into the groundwater. It's a case where there was a problem with the casing right where it went through the groundwater. In other words, in the upper few hundred feet of a wellbore. That's obviously a problem and needs to be mitigated and prevented.
Some of the most important things is to make sure that when you set your casing and you cement your casing, that you do a good job doing that. Because invariably, a lot of the blowouts that we have relate to mistakes made in setting the pipe that we put in there to protect it.
That comes to having, tight standards for the cement that I use for the casing, right? That has to do with what kind of fluids I can use when I drill.
These chemicals should be disclosed to the public so that there is no controversy or question in the public's mind about what kind of chemicals are being injected in the subsurface. In Texas, for example, in 2012, there's a law that's come into effect that requires operators to disclose in a written format what kind of chemicals are being used in a particular fracturing process.
There are a lot of companies that have experimented with coming up with non-toxic fluids. We know that's possible, actually. So let's do it.
The way we're going to work ourselves through this is through a robust, transparent conversation that's bringing science and citizens and industry and responsible government to a place where there can be some degree of consensus.